This example gives us some crazy function, 18 times the quantity cubed root of x minus 1 all over x cubed minus 1, and then asks us to find the limit as x approaches 1 of that whole thing. It would be challenging to do this analytically using various algebraic manipulations, but it tells us in particular to use a calculator to find the limit. I want to stress that using a calculator is not the standard way to find limits, and it's not a habit that we want to get into. But let's do it for this example just to see what happens. The idea is you can just plug in numbers, right? Okay, so first note, if we were to plug in 1 here, right, we're approaching 1. So the first thing to do is just say, okay, well, what happens if we just plug in 1? Maybe that's all there is to it. But note that here, if we just plugged in 1, we'd get 1 cubed minus 1 in the denominator, which would give us 0 in the denominator. You can't have 0 in the denominator. In fact, it'd be even worse than that. It'd be 0 over 0. So that's epically undefined. So we can't just plug in 1, but we can plug in something very close to 1. So let's try a couple values. Let's try something like x equals, I don't know, 1.000000001. And let's also try x equals something on the other side of 1. How about 0.999999999? I don't know, it's pretty arbitrary. And you essentially plug that into your calculator for this function. For this kind of exercise, Desmos is slightly better than a calculator. You can use Desmos.com. There's also a Desmos app. So here we are in Desmos, and the idea here is to define a function so we don't have to keep tapping furiously away on our calculator. So I'm going to define this as f of x equals, okay, and then we need the cubed root of x. How do you do that? Well, I'm just going to do nth root. I think that does it. Yeah, look at that. I typed in nth root, and look what happened. It gave me this cubed root business. Whoops. Of x, what is it, minus 1. And then all of that's actually times 18. So let's do that. Okay. Okay, this is promising. Now we need all of that over, so I'm going to highlight it and then do a slash. That gives us the divided by, and then this x cubed. Let's see, get down from the exponent, minus 1. Oops, minus 1. Okay, there we go. We're using the values right around 1, so let's do let's say 1.0000000. Bunch of zeros, and then 1. 1. It's telling us that it's 2. It's even within the accuracy of Desmos, it's telling us 2. Same thing, f of 0.999, oops, 999, just a bunch of 9s. You can see it getting closer and closer to 2. See how that 2 is changing down there? 999. So approaching 1 from both the right and the left give us essentially 2 for f of x. Though the function is not defined at 1, let's see what happens if we try to put in f of 1, undefined. We can get really close in there and tell that it's obviously going to be 2. So we have used a calculator to say this limit is 2. Again, that's a bad habit to get into, so don't do it often, but it's fun every once in a while just to brute force calculate the limit like that.